Hello, so today in this video, we're going to look at differentiating the function ARTANH of x with respect to x. So in the previous two videos, we differentiated RSinch and RCosh, so the inverse hyperbolic sine and cos functions. So again, ARTANH just means, it's just equivalent to saying like this, tanh minus 1 operator. So RTanh is the inverse tanh function, so the inverse hyperbolic tan function, and we're just going to differentiate this pretty much exactly the same way we did with RSinch and RCosh. So yeah, same technique again as we did in the previous two videos. So what we did was we're going to let y equal the RTanh of x, and then what we can do is apply the the hyperbolic tan function to both sides. And because tanh is the inverse of artanh, what that means is that we're going to get just x on the right hand side, and we'll get tanh y on the left hand side. So sorry, my bad, that should be an x. So tanh of artanh x is x, because the inverse functions remove themselves. So then we get, tanh y equals x. And then the next step is to apply the derivative with respect to x to both sides. So then if we do this, we're going to get d by dx of this hyperbolic tan of y. And that's going to equal dx by dx on the right-hand side. That's just the number 1. Because differentiating x with respect to x is just 1. Okay, perfect. So then we know that d by dx, of tanh y equals the number 1. Now, again, with this left-hand side, we're going to have to do a bit of chain rule to get rid of this, or to rewrite this left-hand side. So we've got, we want to differentiate with respect to x the function tanh of the function y, which itself is a function of x. So this is where the chain rule comes in. So we differentiate this function inside the tanh first. So if we do that, we're going to get just a dy by dx, because that's what the derivative of y is with respect to x. And then we're going to times that by the derivative of tanh of y with respect to y this time, by the chain rule formula. And if we do that, well, we know the derivative of tanh, because we worked out that derivative in a previous video. We worked that out to be sech squared. So the hyperbolic sec function is what sech is. So sech squared of y would be the derivative of tanh of y with respect to y. So great. So what we know then is that dy by dx times sech squared of y equals the number 1, because this equals that up there. Okay, cool. So therefore then, let's write this here. Dy by dx times sech squared of y equals the number 1. Divide both sides to get dy by dx as the subject of the formula, and we get dy by dx equals 1 over sech squared of y. And y, of course, this function y is literally artanh of x, and that's the objective of what we want to differentiate. So we wanted to differentiate artanh of x, and that result would be 1 over sech squared of y. The only issue we have left is that we've got the answer in the variable y, and we don't want that. We want it in a variable x. So again, it's going to be a case of using one of those hyperbolic trig identities. Let me just make the writing a little bit smaller. So again, we're going to need one of our hyperbolic trig identities. And this time the identity we're going to use is this one. So we're going to use the identity 1 minus tanh squared equals sech squared of x. Sorry, I forgot the of x inside there. Just fit the x in to that function. Yep. So we're going to use this identity. So we therefore know that sec squared is 1 minus tanh squared. So we can actually just rewrite this this fraction down there as 1 over 1 minus tanh squared of x. So great, we've got that. And then the last step now then, sorry, my bad, this should be a y, sorry, because we're doing sec squared of y. So sec squared of y equals 1 minus tan, sorry, again, another mistake. It's not tan, it's tanh, so hyperbolic tan squared of y. Okay, right, so then we're nearly there. So if we go back to our working here, so we know that tanh y equals x, so tanh squared equals x squared, and so therefore this equals 1 over 1 minus x squared. And so therefore our final result then is that d by dx of ARTANH of x is equal to 1 over 1 minus x squared. And that is our final result.